Let's say we wanted to make a slight alleyway or tunnel between this room and another room. We could click and drag down to shorten this wall, shift and drag to match on the other side, and now we have an opening. This opening touches the void. So let's start creating our little hallway with a floor. Between these boxes, we'll click and drag. And let's look below, or even in our 3D view, to see that obviously isn't what we want. We're trying for a floor, and that looks more like a room. So zoom out, Z to stop. In the side, or the front view, let's go to the side, zoom in, we're going to scroll this guy down to be only one grid size, or 32 units, tall, and then drag it down until it meets the floor of our existing room. Hit enter to make it solid. And now we have kind of a little lip or jawbridge looking thing coming out of our room. If you look from below, you'll notice it's not intersecting with our wall, which is going to be the most efficient as we move forward. Okay, so now let's take that floor in our side view with the selection tool, shift drag it to the top, and we'll make our ceiling. So let's create our walls. The block tool in our side view, we'll click between our floor and ceiling, and make sure that the block we're adding is what we want. Now it looks like we've gone a little too far into our building. We don't need to. Click, drag out to meet your wall, the outside edge. Zoom in our front view. Whoop. Now, if you happen to click somewhere else in the scene using the block tool, you're suddenly going to be making a new block, which you might not have wanted to do. So go back, draw your wall, shrink it to the one unit that you're wanting, move it out into position on the far edge so that the interior is aligned, and enter to create a solid. With that still selected, go to our top view and shift click it, add the other edge, and now in the 3D view you'll notice that we have a hallway, a rather big one. So let's just make a really small room that it connects to. Or, to be even simpler, zoom out and use another one of the tools from our operations toolbar. With the selection tool, you have the ability to select individual brushes that you've created. If you click and drag, you can also select multiple brushes if you have the toggle auto selection enabled. If the toggle auto selection is not enabled, when you click and drag, you'll simply get a selection box. So if we enable it, we can click and drag around our big room, but anything it touches is also selected. So in this case, it's selecting our new room, or our new hallway. With the selection tool, Control click to remove it. We can remove the room we just created. Then, move this to spacebar, shift drag the room that we had, and align it on the other side of our hallway. Let go. We could then fill in the gap on this side and remove a chunk from our other side, or we could rotate and line it up. The problem here is that rotating in Hammer can be inefficient and not too precise when you're just clicking and dragging. So if we happen to just have this off slightly, when you look in your 3D view, you probably notice you have some gaps don't exist on our other side. If we compiled this, we would get leaks, which we'll go over more later, but would basically not allow our map to run efficiently, be laggy, or not run at all. So, let's undo our rotation, go to Tools, Transform, and let's rotate our room 180 degrees in the Z-axis. If you're familiar with 3D or 3D applications, you should immediately be aware of X, Y, and Z coordinates. But if you're not, just know that X basically runs on the top view lengthwise, Y up and down, and Z just like your eyes if you were staring straight down the center. So we want to rotate basically around that Z-axis, which would be cut straight down the middle of this room, to rotate these points all the way around to here. 180 degrees on the Z. Okay? Boom. Precise. We'll just move our entire object 1 unit in. And now we have a perfectly sealed 2-room with a hallway. Z to stop our movement. And now's a good time to save before we start applying some textures and placing some basic entities which will allow us to run our first map. Go to File, Save As, and we're going to save in the map source folder of Counter-Strike, or map SRC. Now that folder is located within your program files, Steam, Steam apps, your username, in my case Noesis07, Source SDK content, Counter-Strike or C-Strike, and map source. It's very important that this directory is noted, since this is where we'll save all our maps and go back to them later. So let's go through the directory from the beginning. On your local hard drive, go to Program Files, Steam, Steam Apps or Steam Applications, your username, and then under your username, click the Source SDK content folder, the developer's kit content we're working with. The game in the SDK that we're working with now is C-Strike, Counter-Strike, and the map SRC or map source folder. Within that, let's go ahead and name this CS underscore 2 rooms dot VMF. VMF is the Valve map file format. Click Save. You'll see now we have our CS2rooms.vmf. Alright, so now we've got our 2 rooms level saved. And let's talk about some common dimensions that we should start taking into account before we build too much more of our level. And then we'll go through how to use some more of the brush tools to add some more interesting obstacles and make this level a little more exciting. And then we'll get to texturing and make it look a little prettier. Okay, let's talk about some dimensions that we should use when building levels. Counter-Strike and Half-Life and other games in the Source engine have some typical dimensions that our characters have to abide by. Got a little guy and a little 3D obstacle course here for him. Here are some common dimensions you should take into account when building a level for Counter-Strike or Half-Life. The maximum height that any object can be and still allow our character to walk over it is 18 units, either in the standing or crouch position. So any unit taller than 18 units tall, our little guy here is not going to be able to cross it. He's not going to be able to just simply walk over it. Similarly, any overhead obstacle height cannot be any smaller than 37 units for our character to successfully crouch and crawl underneath. And no object can be any shorter than 73 units to have our character walk underneath it normally. The minimum path size that any area must be for our character to successfully squeeze through it is 33 units wide. Any narrower than this, and the character simply won't go through. The minimum height for a path is the same as the overhead obstacle at 37 units. There's also a maximum climbable grade that is 45 degrees. This means that any surface at a greater incline than 45 degrees will not allow our character to walk up it. 45 degrees and he can climb just fine. More than that, he'll just stop, not be able to go up. As far as jumping is concerned, in a crouched position, a character can jump 21 units. This means that 21 units, he can simply jump and land on top of the object in question. From a normal walking position, he can jump 56 units to land on his platform. When you start jumping horizontally, or lengthwise, from a stationary position, our character can jump 84 units. From a running position, he can go further, all the way to 176 units. There are slight variations between Counter-Strike and Half-Life as far as jumping, but these minimums should work just fine in either of your levels, and allow a novice to jump to any platform that you intend them to. Alright, let's go back in the hammer. And let's add some obstacles to make our level a little more dynamic. Now with our block tool, we could create some more walls and obstacles here, but let's say we want something that's not a box. Our block tool, it may surprise you, can do a bit more than just draw blocks. If we select it and go to our new object toolbar, you'll notice under the viz groups, we have categories as primitives. Now categories for the block tool are primitives, prefabs, or prefabs Half-Life 2. We'll go through prefabs a little bit later. Right now, the majority of our building is going to be primitives. So make sure primitives is selected. And under objects, we get a list of other objects other than just block, which we can create. We have arches, blocks, cylinders, spheres, spikes, torus, or wedges. And let's say we want to create a pillar right in the middle of our hallway. We'll select cylinder from the list, and we get a choice for the number of faces in our cylinder. And 8, maybe a little more stop sign than we want. We want a little rounder of a pillar. So let's just double that to 16. Zoom in to our hallway. And with the block tool, we want to draw a square. But we can't put it currently right in the middle of the hallway where we'd like it. We're going to need to use the brackets to shrink the grid size to something more around the lines of 8 or 16 and center our block within our hallway. Now, with cylinder selected, if we press enter or right click and select create object, we'll create our cylinder. But we put it into our wall and ceiling, which we don't want. So with the selection tool, shrink it down and make sure there's no overlap and it's sitting securely within our hallway. So now we just need to make sure we've given our character enough space to walk on either side. You can count on the grid 4 and 4 units, but what does that represent? Let's use our selection tool. Just start clicking and dragging a box. Those 4 units, in this case, since there's 16, equals 64. Now, do you remember if that's enough for him to walk? Let's check. Our minimum path size width for a character to walk successfully through is 33. We basically all but doubled the space necessary. So it should work out. We have enough space on either side for the character to walk. Okay, let's zoom out a bit.